Hello and welcome to my YouTube channel Civil Line. Myself Milan Patel, Assistant Professor at LJIET Institute of Engineering and Technology. Today we start a new chapter which is Modern Tools and Techniques. This is the first lecture of this chapter. Basically, this chapter can be divided into two topics. First is Modern Tools and second is Modern Techniques. In Modern Tools, we will discuss Theodolite and total station, while in Modern Techniques, we will discuss GPS, remote sensing and GIS. In today's lecture, we will cover first modern tool, Theodolite, and second total station in detail. So let's start with Theodolite. A theodolite is a precision optical instrument used for measuring angles between designated visible points in the horizontal and vertical plane. This instrument can be used for measuring horizontal as well as vertical angles. In angular measurement chapter, we have discussed compass for angular measurement. So, what is the difference between a compass and a theodolite? Let's discuss. How theodolite is different compared to the compass. Okay? In compass measures horizontal angles only. It cannot be used for measuring vertical angles, while theodolite can be used for horizontal as well as vertical angle measurement. Second is accuracy. Compass is used for accuracy up to 30 minutes, while theodolite can be used for accuracy up to 10 seconds or 20 seconds. Okay, so theodolite is more accurate compared to the compass. And the third, compass measures the bearing of the line with respect to some reference line, which is called as meridian line. Okay, and the angle between two lines can be measured by taking difference between the bearings of these two lines. Okay, while in theodolite directly measures the angle between two lines. Okay, it cannot. Now let's discuss various uses of theodolite, where this theodolite can be used. Okay, first is to measure horizontal angles. It is also used for measuring vertical angles. It is used for measuring deflection angles in beams or columns. It is also used for measuring magnetic bearings of the lines. It is used for measuring horizontal distance between two points by taking number of angles. Next is to find out height of the object. It can be done by taking the vertical angle of the object and the distance from theodolite to the object. Seventh, it is used for finding out the height difference between two points. Next is to measure a slope. Theodolite can be used. Next is it is also used for ranging the line. Okay. And the last is it is used for extending the line. Okay, these are the various uses of theodolite. Okay, now let's discuss the classification of theodolite. Okay, theodolite can be classified into two categories based on movement of telescope, and second is based on arrangement to measure the angles. Okay, first is based on movement of telescope. Theodolite can be classified into two categories: transit theodolite and non-transit theodolite. Okay, let's see the difference between transit theodolite and non-transit theodolite. In transit theodolite, telescope can be rotated about horizontal axis in vertical plane through 180 degree. So you can rotate the telescope through 180 degree like this. While in non-transit theodolite, telescope can be rotated about horizontal axis in a vertical plane through some limited angles, about 45 angle or 60 degree angle. Okay. Second, in transit theodolite, the position of theodolite can be changed from face left to face right condition. So what is face left condition? What is face right condition? We will discuss by this figure. If this vertical circle is on the left side of the observer, it is called as face left condition. If this vertical circle is on the right side of the observer, okay, it is called as face right condition. Okay, transit theodolite, the position of theodolite can be changed from face left condition to face right condition because the telescope can be rotated through 180 degrees. and it is also rotated in horizontal plane like this by this number of clamp screws. Okay. In non-transit theodolite, the position of theodolite cannot be changed from face left to face right condition because the telescope cannot be rotated 180 degree like this. So it cannot be changed from face left to face right condition. Next, transit theodolite can be used for ranging the line by doing back sighting, while non-transit theodolite cannot be used for ranging the line done by back sighting. Okay? Transit theodolite are widely used nowadays in surveying, while non-transit theodolite are now become obsolete. It cannot be used nowadays. Okay? These are the difference between transit theodolite and non-transit theodolite. Now let's see the classification of theodolite based on arrangement to measure the angles. So based on arrangement to measure the angles, theodolite can be classified into two categories: Vernier theodolite and micrometer theodolite. So what is Vernier theodolite? In Vernier theodolite, Vernier scale is installed to measure the angles, while in micrometer theodolite, micrometer is installed to measure the angles. Okay. So what is more accurate, Vernier theodolite or micrometer theodolite? Let's see. In Vernier theodolite, accuracy up to 20 seconds can be achieved. Okay. While in micrometer theodolite, accuracy up to 1 second is achieved. So micrometer theodolite is more accurate compared to Vernier theodolite. Nowadays, transit Vernier theodolite is widely used for surveying. Okay. Now let's see the components of transit Vernier theodolite. This is the image of transit Vernier theodolite. Okay. Let's see the components of transit Vernier theodolite. Okay. The below portion is the tripod leg. This instrument is clamped on the tripod by clip screw. Okay. The below portion of this theodolite is having leveling head. This portion is called as leveling head. In leveling head, three components are there. This lower triangular plate is called as tripod. This upper triangular plate is called as tri-bridge, and these three screws are the foot screws. This leveling head is used for leveling the instrument on the tripod. Okay. Above leveling head, number of circular plates are there, which is used for measuring horizontal angles. This portion in theodolite is called as horizontal circle assembly. In horizontal circle assembly, there are mainly two circular plates are there. Lower circular plate having graduations from 0 degree to 360 degree. The minimum count in this plate is 20 minutes. Okay. The above plate is called as upper circular plate, or it is also called as Vernier scale. Okay. Having graduations from 0 minute to 20 minutes, having minimum count of 20 seconds. So the least count of this instrument is 20 seconds. This type of theodolite can be used for measuring angles up to 20 seconds. Okay. These two plates can be rotated with the help of clamp screw and tangent screw. There are two clamp screw and there are two tangent screws are there. In lower circular plate, one lower clamp screw and one lower tangent screw is attached. In upper circular plate, one upper clamp screw and one upper tangent screw is attached. These screws are helped to rotate these plates about horizontal axis. Okay. If lower clamp screw and upper clamp screw are fixed or clamped, this instrument cannot be rotated in horizontal axis. If upper clamp screw is released and lower clamp screw is fixed, so this portion, lower circular plate cannot be rotated. This upper circular plate can be rotated about horizontal axis. Okay. So for reading or for taking horizontal angles, lower clamp screws should be fixed and upper clamp screws should be released for taking the horizontal angle measurement. If upper clamp screw is fixed and lower clamp screw is released, then the rotation of these two plates are like this, combined manner, in combined manner. Okay. So this is how clamp screw is worked in this theodolite. The tangent screws, lower tangent screws and upper tangent screws are helped for rotating these two plates in slow motion. or for slight rotation. Okay. Above these circular plates, one Vernier scale is attached. This is the Vernier scale. This is the prism for taking the readings. Okay. There are two Vernier scales are there on this side and on the opposite side. Okay. This is the standard, or you can say a A-frame, which is holding this telescope. One eyepiece is there, one object glass is there. Okay. And this is the horizontal circular plate. This is the vertical circular plate. This vertical circular plate can be used for taking vertical angles or for measurement in vertical plane. Okay. This is the bubble tube, you can say. It's also shown in this figure also. This is the plate level, is the one type of bubble tube which is used for leveling the instrument in horizontal manner. Okay. This above portion, above vertical plate, there is also one bubble tube is there which is called as altitude bubble tube, which is used while taking vertical measurements or while taking vertical angle measurements. Okay. So these are the various components of transit vernier theodolite. Okay. Now let's see how the readings can be taken in theodolite. Okay. This is the lower circular plate, or you can say main scale, having graduations from 0 degree to 360 degree. The minimum or smallest division in this main scale is 20 minutes. This is the upper circular plate, or you can say Vernier scale, having graduations from 0 minute to 20 minutes. Okay. Having smallest division is 20 seconds. Okay. Now let's see how least count can be found out in theodolite. Least count can be found out by this equation 1 upon n into smallest division of main scale, where n is equal to number of spaces in Vernier scale, which is 60. Okay. Smallest division of main scale is 20 minutes. So least count is 20, which is in minute, can be converted into second by multiplying 60. So the least count of this theodolite is 20 seconds. Okay. Now let's see how the readings can be observed in Vernier type of theodolite. For taking readings, we have to match the graduations of main scale and Vernier scale. If one of the graduation is exactly in line with Vernier scale graduation, the readings can be observed. Here, this arrow shows the graduation which is exactly in line with Vernier scale. Okay, like this. This is in line with Vernier scale graduation. Okay, so the readings is like this. First of all, we have to take the reading in main scale. Here in main scale, the reading is 55 degree and 40 minute, because the smallest division in main scale is 20 minute. So this is the 55 degree, 20 and 20 minute, which is 40 minute. So the main scale reading is 55 degree, 40 minute. Now let's take the reading on Vernier scale. The reading in Vernier scale is 3 minute 40 seconds, because the smallest division in Vernier scale is 20 seconds. So 3 minute 20 seconds plus 20 seconds, so 40 seconds. So the reading in Vernier scale is 3 minute 40 seconds. So the final reading is the summation of this main scale and Vernier scale reading, which is 55 degree, 43 minute and 40 seconds. This is how the readings on theodolite can be taken. Now let's move the second topic in today's lecture, which is total station. This is the second modern tool nowadays used. A total station or a total station theodolite is an electronic or optical instrument used for surveying and building construction nowadays. It is an electronic transit theodolite integrated with electronic distance measuring machine or measurement tool, okay, which is also called as EDM. This is the image of total station. Let's see where this total station can be used. This total station can be used for measuring number of type of readings. First is, it is used for distance measurement. It is also used for horizontal as well as vertical angle measurement. It is used for measuring the elevation of the object. Next is, it is used for finding out the height difference between 2 points. Next is, It is used to find out the height of the point above datum. Next is, it is used to find out the coordinates of the points. And the last is to find out area and volume of the land or plot. Total station can be used. Okay, these are the various uses of total station. Now let's discuss the features of total station. Okay, this is the figure of total station showing number of features of that. First feature is control panel. This Theodolite consists one keyboard and LCD display on it to control or to take measurements or to store the readings. Next is angular measurement. This theodolite can be used for measuring horizontal as well as vertical angles. For that, number of arrangements like horizontal clamp screw, horizontal tangent screw, vertical clamp screw, vertical clamp tangent screw, telescope is there. Okay, which are the same arrangement which is given in theodolite also. Okay. Next feature is distance measurements. This total station can be used for taking horizontal, vertical as well as slope distance. For taking horizontal distance up to 1 kilometer, single prism assembly is used. For horizontal distance up to 1 to 9 kilometer, 3 prism assembly can be used. Okay. Next is internal or external memories. For taking or for storage of the readings, internal memory or memory card is there, having storage capacity up to 1000 to 16,000 points. Okay. Next is data recording and transferring. For data recording, handheld computer, memory card, data logger, data recorders are there. And for data transferring, data cable or card reader is installed in this total station. Next is for power supply, rechargeable nickel cadmium battery is installed in this total station, having usage time is 2 to 10 hours based on the manufacturer. Next is accessories. With total station, 3 accessories are there. One tripod is there for attaching this total station, ranging rod is there, and one prism is there, okay, for taking readings. Next feature is reflector-less distance measurement. This total station can be used without using the prism for distance measurement. This is called as reflector-less distance measurement. Next is graphic display. This total station having large display panel showing number of points or number of readings in it. Okay, these are the various features of total station. Now let's see various advantages of total station. First advantage, the work carried out by total station is rapid. Its accuracy is high. Reading can be stored and transferred to the computer easily with the help of data cables. Coordinate of points can be calculated easily, and with the help of computer you can easily prepare contour map, cross section of the roads and area of the field. Okay, these are the various advantages of total station. Now let's see the disadvantages of total station. It does not provide hard copies of field notes, so it is difficult to check the work while surveying. For overall check of accuracy, it is necessary to return to the office and prepare drawing using appropriate software. You cannot check the work on the site. The instrument is very costly. This is also one disadvantage of total station. The cost of total station is about 3 to 5 lakhs. Next is skilled person is required for survey. Normal labor or normal person cannot use this type of instrument. Okay, these are the disadvantages of total station. I hope you all understand these two modern tools, Theodolite and total station. See you soon in the next lecture. Thank you for watching. Don't forget to like, share and subscribe to my YouTube channel, Civil Line. Thank you.